All right, let's get right into it. When you're building modern software, you're not just slapping features together. You are designing a system. And the way you connect the pieces of that system, well, that's going to decide whether it soars to new heights or grinds to a screeching halt. Today, we're talking about the architectural pattern that's the secret sauce behind the biggest names in tech. I'm talking Netflix, Uber, you name it. Event-driven architecture.
I want to kick things off with this quote, because this right here, this is the whole game. Our entire industry loves to run on happy path thinking. This API call will always work, the network is totally stable, but as architects, we don't have the luxury of being optimistic. Our job is to design for the real world, a world where things break, all the time. And that's really the heart of what we're going to break down today.
So here's how we're going to tackle this. First, we're going to unpack what I call the Synchronous Trap. It's the default way most people build things, and it is filled with hidden dangers. Then, we'll get to the good stuff, the promise of event-driven architecture, the elegant solution that decouples everything. But, and this is a big but, we're not just going to talk about the hype. We'll do a serious reality check on the hidden costs, because nothing in architecture is free. And finally, I'm going to give you the architect's playbook, the actual battle-tested patterns you need to build systems that are truly production-ready.
To really get why this is a trap, you've got to understand the two basic ways services can talk to each other. Think of synchronous communication like a phone call. You dial, you ask a question, and then you just wait. You are stuck on that line, holding, until you get an answer. It's direct, sure, and pretty simple to follow, but what happens if the person on the other end puts you on hold forever? Your entire process is blocked. That, right there, is the trap.
And this leads to what I consider the ultimate anti-pattern, the distributed monolith. This is where things get really ugly. You've gone through all the pain of breaking your application into microservices, but then you just chain them all back together with these rigid blocking phone calls. So if one little service slows down or fails, guess what happens? A cascading failure brings down the entire system like a set of dominoes. You've just inherited all the complexity of microservices and all the fragility of a monolith. It is literally the worst of both worlds.
So how do we escape this mess? This is where we need a completely different way of thinking. This is the promise of event-driven architecture, or EDA. The fundamental idea here is to stop requesting things and start broadcasting that things happened. It's a total mindset shift from building systems that wait to building systems that react.
The engine that makes all this magic happen is a beautiful pattern called publish-subscribe, or pub-sub. It's so simple, it's brilliant. Instead of services talking directly to each other, a publisher just sends a message, an event, to a central broker. Think of it like a town crier shouting news in the square. Then any number of subscriber services who are interested can listen for that news and react. But here's the kicker, the absolute game changer. The publisher has no idea who's listening. It could be one service, it could be 1,000. That is what we mean by true decoupling.
Let's make this real. Imagine an e-commerce site. A customer hits buy. In the old synchronous world, the order service would have to call the billing service and wait. Then call the shipping service and wait. Then call the notification service. No. In an event-driven world, the order service simply publishes one single event. Order placed. That's it. Its job is done. A message broker like Kafka catches it. Then, completely on their own, the billing service, the shipment service, and the notification service all pick up that same event and do their jobs in parallel. They don't even know the others exist.
And that right there shows you the massive advantages. Services are now loosely coupled, you can completely change the shipping service, and the order service doesn't care. You can scale just the consumers you need to handle a huge traffic spike. And hey, what if your notification service goes down for an hour? Who cares? The rest of the system just keeps on chugging along, processing orders. That is what resilience actually looks like.
So what does this enable in the real world? Let's talk scale. At its peak, Shopify's event-driven backbone processes 66 million messages per second. Just try to wrap your head around that. There is absolutely no way you could achieve that with a synchronous chain of calls.
This also delivers incredible resilience. Payment systems built with these asynchronous patterns, they achieve 99.99% uptime. Your traditional architectures often top out around 97.5%. That might not sound like a huge difference, but trust me, that translates to hours of very expensive downtime every single year.
And it makes you faster. A major retailer switched to a microservices architecture built on these principles, and they cut their feature launch cycle by 85%. How? Because their teams could finally work in parallel without blocking each other. That's real developer velocity.
Okay, I know what you're thinking. This sounds amazing. It's the silver bullet, right? So why isn't everyone doing it? Because now we get to the architect's reality check. Event-driven architecture is incredibly powerful, but it is not simple. And it comes with a whole new class of problems that you, the architect, have to solve.
So here are the trade-offs you are making. You need to go into this with your eyes open. Your system's logic is now distributed, which makes it way harder to understand and debug. You're trading that simple, immediate consistency for something called eventual consistency. You lose that clear request-response path, making observability a massive challenge. And you now have a new piece of critical infrastructure, the message broker, that you have to manage, secure, and scale.
Let's really drill down on that eventual consistency piece, because it's a big one. It's actually a simple idea. You add an item to your shopping cart on your phone, and maybe it takes a second or two to appear in the cart on your laptop. For that brief moment, the system's state is inconsistent. And that's okay. The system is making a conscious trade-off. It's choosing to prioritize availability and speed over guaranteeing that every single part has the absolute latest data at the exact same millisecond. And you have to design for that.
So given all these new challenges, how do we build systems that are both powerful and manageable? How do we do this without going completely insane? Well, we use established, proven architectural patterns. This is the playbook for taking event-driven architecture into production. Okay, so what about those complex workflows, like placing an order, where it all has to succeed or it all has to fail? You can't just wrap a database transaction around 5 different microservices. So for that, we use the Saga pattern. Think of a Saga as a sequence of local transactions. If any step fails along the way, the Saga is smart enough to execute compensating transactions, to go back and undo the steps that already succeeded. It's how you achieve that all-or-nothing integrity in a distributed world.
Now there are 2 main ways to build a Saga. With Choreography, each service just listens to events and knows what to do next, like dancers in a performance. It's very decentralized and super loosely coupled, but trying to debug it can be a nightmare because the logic is spread out everywhere. The other way is orchestration. Here, you have a central coordinator, a conductor, that tells each service what to do. It's way easier to follow the logic, but you've created a central point of control. Choosing between them is a classic architect's trade-off.
And speaking of debugging, let me be crystal clear about this. If you go event-driven, observability is not optional. It is non-negotiable. You absolutely must invest in distributed tracing tools, things like Jaeger or Zipkin. They are the only way to stitch together the journey of an event as it flows through all your different services. Without them, you are flying completely blind. And trust me, you will regret it.
So let's bring all this home. Let's create the final blueprint. When you're making this decision, synchronous versus asynchronous, what is the core choice you, as an architect, are really making? You know, it's not really about technology. It's a strategic balance between 2 powerful forces. On one side, you have developer velocity. That's the raw speed you get from decoupling teams and letting them innovate independently. On the other side, you have what I like to call architectural sanity. That's the discipline, the tooling, and the sheer effort required to manage all this new complexity and make sure the system doesn't collapse under its own weight. Your job as an architect is to find the perfect balance for your organization.
And that leaves us with a final question to think about. We know we can build from massive, mind-boggling scale. The patterns are there. But as we do that, as our systems get more and more complex, is the real challenge building bigger systems, or is it building systems that we can still understand, systems that have clarity? It's a question every single architect has to answer for themselves. For more tech industry insights for your career or business, go to aaronwillbuilds.com or subscribe to this channel, link in description. Join the inner loop by getting in the email list. Let's level up our business and career from an architect's perspective.